279, there it is, page 238, 239. Looks like all our action, though, is over there on page 239. We mentioned this off camera, but nothing really new we're learning at all in this lesson at all. It's just combining two concepts we've been working with this year. Our knowledge of algebra, doing the opposite order of operation to solve equations, and our knowledge that we have of adding and subtracting with fractions and mixed numbers. What are we doing here? Looks distracting for all of them. So I'm going to start with number 2. Looking at page 239 here. And name of the game here is adding and subtracting. So I'm not going to use K, I'm going to call it N. Okay. So what we're doing here, we're trying to figure out what N is. Somewhere in the world, if there's a number that exists and I add 5/8 to it, I get an answer or a sum of 3 1/8. So what I'm trying to do is figure out what that value is. What does N equal for a real number to plug into there? And what we need to do is ask ourselves, you always isolate your variable when you're doing algebra work. You need to undo or do the opposite order of operations. So commutative property, I can write things in any order I want, if it helps. I mean, this is the same thing here because it's just adding. But regardless of, what am I doing to N? I'm adding 5/8 to it. How do I get rid of that? How do I undo that? I do the opposite order of operation. And the opposite of adding 5/8 to something is subtracting 5/8. And that will indeed remove that add 5/8 and leave N by itself, but to be truly equal, just like the scale, if I'm taking 5/8 from this side here, the scale is no longer equal until I take 5/8 off from this side too. Until that's done, we're just writing numbers. We haven't done any work here. So I need to, again, there's my equal sign. Think about it like the wall. Whatever happens on one side has to happen on the other to keep it truly equal. So if I take 5/8 off that left side, I need to take 5/8 off that right side too. And when that's done here, on the left side here, the 5/8 minus 5/8 basically cancels each other out. If I subtract it, I get 0/8. 0 divided by anything is 0, and adding 0 to anything doesn't change the value. I could write 0 plus n, but there's no point. There's no point. So now n is all by itself, and that leaves me here on the right side of the equation with pretty much this math problem to solve. 3 1/8 minus 5/8. Probably want to break one out, put it back in. 2 9/8. Now I can subtract 9/8 minus 5/8 is 4/8. 2 minus 0 is 2. Always simplify. 2 1/2. And again, if I can certainly test it real fast. If the n is 2 and I'll just leave it here. 2 4/8. Plug it back in. 2 4/8 plus 5/8. 5 plus 4 is 9/8. 2 plus 0. I get 2 9/8. Simplified the 9/8, 1 1/8 plus the 2. There I am, right back to 3 1/8 where this whole thing started. So, if you're so inclined or need to or want to, you can check it. Plug your answer back in, run the equation. Does 5/8 plus 2 4/8 equal 3 1/8? Yes, it does. 2 9/8. Answer's good. 2 1/2. Number 4. D minus 3/5 equals 4/5. And again, I'm saying there's some number that exists that when I subtract 3/5 from it, I get an answer or a difference of 4/5. Give me a moment here, but the same process that we're using today is always going to be the process. The only difference is in future years is there's going to be more than just one order of operation going on. Next year, you'll get introduced to two-step equations, or maybe at the very end of this year, if there's time, two-step equations, where, as you would assume, there will be two different things you have to undo, not just one. And there's an order you go about doing them here. But it'll still be, instead of undoing just one thing, you'll have to undo two different things. And then there'll be grouping equations, multi-step equations, equations solving for multiple variables at the same time. So, but it's always going to be the same. You're always going to be undoing stuff, trying to get that variable all load on one side. The only difference is they'll be longer and there'll be more adding, subtracting, multiplying, dividing. Things you have to get rid of along the way. But look at it, ask yourself, so what am I doing to D? I'm subtracting 3/5 from it. What is the opposite of subtracting 3/5 from something? It would be adding 3/5 to something. Whenever I do on one side of the equation, I must do the same to the other. Keep that scale balanced. So on the left side, D is all alone, 3/5, negative 3/5 plus, however you want to think about it, 3/5 minus 3/5, negative 3/5 plus positive 3/5. Either way, I got 0/5 though, yes? Yeah. So I've eliminated it. But then on the other side, 4/5 plus 3/5, 7/5. And then of course, this is a final answer, so that needs to be simplified to 1 2/5. And again, easy to check. 1 2/5, same thing as 7/5. 7/5 minus 3/5. 7 minus 3 is 4/5. When I plug it back in here. And again, I'm just using this form because it's much easier to check this answer than this answer in here, right? 7 minus 3 is 4. Answer's good. Answers make sense. If you look at it from the other way, just close your eyes to everything. All I really did was add 4 plus 3 to get 7. And then I had to simplify it. Yes? Yeah. Okay. 2 for you. I'll pull 2 sticks here. All right, 6 and 7. Number 6, x minus 4/7 equals 5/14. And number 7. I'm not going to write t, I'm going to call it n, plus 2 and 1/6 equals 7 and 11/12. All right, 6 and 7. And then we got one more thing we got to look at here. In a way, there's 2 totally separate things going on here. One, you gotta make sure you're setting it up properly algebraically, making sure that you're doing the same thing on both sides. And then 2, you have to use, solve an adding or subtracting problem with fractions. Those are 2 totally different concepts in a way that you gotta do to get to the correct answer. So both of them have value. I mean, truly the most, if you can understand, I would be much happier if you could set it up properly and did the adding, subtracting part wrong than the other way around, but alright, number 6. For Jackson, number 7, Dom. Pretty exciting there, huh? All right. Jackson, you ready?
Yeah.
All right. What are you seeing? What do I got to do here?
First, since what you're doing to x is you're subtracting 4/7 from it, so subtract add 4/7 to 4/7.
Yep.
Cross that out. And then add whenever you do that side, you gotta do the other side.
Yep.
And then multiply 7 times 2 and 4 times 2, you get 8/14. And add rows, you get 13/14. 14.
Right.
X equals 13.
That is exactly correct. Yep, so he hit them both. So first he undid what we needed to do to get the variable all by itself. And then second, he correctly walked through the addition problem he needed to solve. So good. Dom?
Alright, number 7. Wait. So since you're adding 2 and 1 6, you gotta do opposite. So you subtract 2 and 1 6 on both sides.
Yes.
And then I rewrote the common denominator, but that's 2 12. So yeah. And then 11 minus 2 is 9 12. And then 7 minus 2 is 5. We gotta simplify that. So it's 5 and 3/4.
You did it. Yep, perfect. Again, just same deal. He did both things he needed to do. He subtracted the right value to get n all by itself, undoing adding 2 and 1 6. Did it to both sides to keep it the scale balanced. Solve your subtraction problem, get your common denominator, peel through it, simplify as needed. There it is, 5 and 3/4. Okay, let's look at number 1 here. Back to number 1. So this one's a little different. Number 1. Okay. And we need to be careful here with this. So we have seen subtracting variable problems earlier this year. This did not go real well for most of you, this concept. So here we go again. Definitely advise most of you to pay it because when you saw this earlier this year, you did not get them correct on quizzes or tests. So here's what we got. What I'm saying is, and you could probably see the answer right now, get rid of the thing here. If I said 7 minus something equals 2, just get rid of the denominators altogether, you could probably envision that the answer is 5. 7 minus 5 equals 2. So what am I missing? I'm missing 5/9 here, right? But here's the deal. If I try and get this isolated here and subtract the 7/9, it's not impossible here. This is probably not, you don't really have the skills to do it quite this way. But if I did this here, because I'm not subtracting 7/9, in a sense I got negative y plus 7/9 going on here. That is a positive 7/9, right? The only way to get rid of it would be to subtract it. But then what's going on this side here? What's going to happen when I do 2 minus 7/9?
You can't do that.
Right, officially I can't. Once we get next year, we did work with integers, and officially it would be a negative 5/9 is our answer. But we'll get into that more next year. So that's probably not, that's not going to work for us with what we have in our tool belt today. Okay, so back to it. What would I want to do? And the book kind of goes through this here. I'll kind of show you the same way, but here's the whole thing. Add the variable to both sides. To solve the equation, they have that similar situation where we're subtracting k. But what we do here is instead of having this subtract the variable situation, we always want the variable in a positive state. Essentially, this is, for all practical purposes, adding a negative. And we never solve for the opposite of a variable, or the negative of a variable. So our variable needs to always be positive. It has to be. And we'll learn, again, a more efficient strategy next year where maybe I showed it, the multiply by -1 technique at the end. Does that resonate with you? Not so much. So what we want to do here is we want to add the variable to both sides. All right? Because I don't want this subtracted. Every other one, again, I wasn't subtracting the variable. I'm subtracting 4/7. I'm adding something. I'm subtracting something. I'm adding it there. They were always positive. But when I'm subtracting the variable, I need to rewrite the equation first. It has to be my first move. Write it out if you want. When subtracting, if you want to write it, write it. If you don't, fine. I don't care. Variable, such as this scenario right here, when you're subtracting the variable, I'm just going to put must for today. Must add the variable to both sides first. Has to be your first move. for today. But I would just consider using this blueprint and just sticking with this here. So when I add the variable to both sides, what happens to my whole equation here? And just like if y was 2, I mean, it doesn't matter what y is. No matter what y is, pick anything you want y to be. Whatever it is, when I subtract it from itself, I get an answer of 0 every time. Doesn't even matter what y is, right? Right? And the book kind of, again, shows it this way here. Whatever it is, when I subtract it from itself, there's nothing left. In a sense, I've canceled the variable out, is what I've done on the left side, but where it hasn't gone, I just moved it to the other side of the equation. And why did I do that? I did it because I want to get it as a positive, not the subtract. So rewrite everything how it is. 7/9 is on the left side by itself. And on the right side, I still have my 2/9, but there's my variable. There it is over there. So it's reappeared. Now I can go ahead and solve the equation the same I did as other. What am I doing to y? Adding 2/9 to it. How do I undo that? Subtract 2/9 from both sides. And then I got 7/9 minus 2/9 is 5/9. Y equals 5/9. 7/9 minus 5/9 equals 2/9.
So what
Right?
so, yeah.
7 minus 5 equals 2. What's your question, Deb?
I didn't have one anymore.
No question?
No.
Okay. So try number 3. 2 3/10 minus g equals 1 1/5.
Are we gonna pull a stick this time?
No, I'll walk through and then I got 3 more and then I think we're good.
Okay. When are you leaving?
Like at 10:35.
Oh. Just for leaving that.
So, and again, subtracting this from that would lead us into negative territories and trying to do negatives with fractions. Again, we do that next year in depth. So, but for now, it's a little challenging. So first thing I'd want to do, again, I'm always aware before I start working, take a moment to just look at the problem and consider what you got to do. Instead of just blazingly trying to go through, you may miss something that way. But as soon as I see this, I realize this situation needs to be resolved first. In a sense, I'll tell you this again about algebra. There's a 3-step process. There's the pregame part, and this is pregame work, where I combine like terms, I simplify where possible, whatever I got to do. But then once all my pregame's done, then it's on to the game. So this is pregame work here. This is stuff I do before I can even attempt to solve the equation. And this is natural with algebra. You have to do this pregame. You can't just instantly go to start solving the thing and doing adding and subtracting stuff. It's not usually how algebra works. So pregame work. We got some pregame. Once you got your pregame done, there it is. Now it's all set up. Now I can get on to the solve part here. Now I can get on to the solve. And what am I doing to g? Adding that 1 1/5. How do I undo? Subtract from both sides. Gone. Common denominator, 2/10, 3/10 minus 2/10, 2 minus 1. G is 1 1/10. Once we get higher level algebra, again, there'll be post-game work to do too, where you have to, again, combine and simplify more and deeper and stuff like that. But, right, I mean, okay. Last 3. So, H minus 1 5/8 equals 3 1/8.
Is that number 5?
Yep. Number 8.
Do we have to do the year thing to it every time?
I'm open-minded to how you want to solve. If you're getting them correct, I probably like your method. So I will give you the benefit of the doubt. But there is, again, definite value. I mean, down the road, these equations will get more, not more this year really, but maybe at the last couple weeks of school, we'll see where we're at and what we want to do with those days. But
Number 8.
to excel down the road at algebra, I mean, it requires a decent amount of writing. Most of you guys, I mean, you guys are really good at putting forth that hard work,
I'm
and,
really
and
good at writing.
well, you guys are, and that's the fundamentals. It's learning to dribble the basketball. It's not exciting work. Everybody wants to shoot the 3-pointers, but you know, you got to be able to just dribble the ball. And this is learning the proper template and format and ways to go about considering these types of problems will carry with you far beyond this classroom. So.
Probably are very good.
And yeah, I mean, this is it. We'll have our fractions chapter next year. It's intense. It's intense. Chapter 5, your last chapter you'll have without your calculator in your hand next year. So, but the hope is, at this point here, you can carry with you beyond. You know, you just know how to add and subtract fractions. We don't have to explicitly teach you how to do it again. And I will go through it a bit next year, but it'll be much faster, and we'll have negative values in there too, pretty quick. So you'll be constantly considering your rules of addition throughout the year. Yep, bring it home. Quiz tomorrow on these 3 sections. 7-7, 7-8, 7-9. 7-7's that mental math day. Again, you can look for on your quiz. All I ultimately care about, Damien, don't need that now. Ultimately, all I care about is the correct final answer. Your means to get to it is up to you, but there will definitely be some shortcuts on the quiz if that's your thing. Otherwise, you'll be grinding some out tomorrow. The expression stuff that we just checked seemed like the homework went well when we checked it. And then today's stuff, algebraically, combining those 2 concepts throughout this year. Our algebra work, our adding and subtracting fraction work. So.
It just looks like he's not good at
Okay, number 5, Evangeline. Y'all ready? All right, walk me through it, boys.
So first you have to add 1 and 5/8 to 3 and 1/8.
Tom, I'm trying to hear her talk.
And then the common denominator is 8, so that equals 4 and 6/8.
Yep.
And then you simplify and it turns into 4 and 3/4.
Yes, it does. Yep, perfect. What am I doing to H? Subtracting 1 and 5/8 from it. How do I undo that? Add 1 and 5/8 to both sides. Good. Number 8, Damien.
Okay. So, I added 10 and 1/2, or I added 8 and 3/8 to 10 and 1/2, and I got, what did I get?
Well, if I add 8 and 3/8 to both sides, then I'll have 16 and 6/8 on this side.
What?
I wouldn't want to add that. Nope, nope. Look closer.
I don't know.
Anybody, what do we gotta do first?
You have to add maybe the both sides.
Right, this is, again, our first thing, when we're dealing with the subtract, that we have to resolve this first. So my first move has to be to add the variable to both sides, because I can't, this is a scenario I have to be on the lookout for now at this juncture. And they'll dot it in the homework too, so you gotta be looking for it. But yep, so we add the so what's my new equation, Damien, when I get rid of u and move it to the other side? What's my new equation?
10 and 1/2 minus 8 and 3/8
10 and 1/2,
plus 8 and 3/8.
my equal sign, equals, and what do I have on the right side now?
8 and 3/8.
Yep,
I can't see it.
plus u.
Oh, yeah.
Because again, remember, I added the variable to both sides. Why did I do that? Because I have to undo this subtracting variable scenario first. It has to be done first. It has to be. When you're subtracting variable, you must resolve this variable thing here. You just have to. So now, here's my equation. So now what do I want to do to solve it? I'm adding 8 and 3/8 to u, so I
Subtract.
subtract what?
We subtract u from 10 and 1/2.
I don't need to subtract u. U's good. I'm solving for u now. I want to undo whatever's
You subtract.
order of operation is attached to it.
You subtract 8 and 3/8 from 10 and 1/2.
Right. So now, on the right side, again, u's all alone. So what's 10 and 1/2 minus 8 and 3/8?
It is, you would take the common denominator is 8, so it goes into 8 4 times, and you don't need the common denominator for 3/8.
Yep.
And then 4 minus 3 is 1, so you get 1/8 for your, fractions. And then 10 minus 8 is 2, so then 2 and 1/8.
Right, and there would be our answer there. And again, if I plug it back in, let's plug it. Now I know what u is, so 10 and 1/2 minus, what's u? U is 2 and 1/8. 4/8 minus 1/8 is 3/8. 10 minus 2 is 8. Yep, there it is. When I plug it back in and test my answer inside the equation, it works. If I just reasonably think it through for a second, just get rid of the fractions and just look at it this way, 10 minus something equals 8, you would probably go, well, 2, right? So now I just throw the fractions back into it, but when you're solving it, you should be expecting an answer probably somewhere around 2. Because 10 minus 2 equals 8. So if you don't get an answer around 2, that would probably be a sign that, wait a second, I did something wrong here. You are not going to get negative final answers. It's never going to be a negative value here at this point or something like that. So could you get a negative answer? Definitely. Next year, will that be the deal? Absolutely. Will it be this year? No. No. So if somehow you're going through and you get some sort of negative or you're in that realm, you did something wrong. You definitely did something wrong. All right, number 10. 6 not here. Brooke.
Number 10. Okay, so first you. Okay, so first you add 2 and 1/4 to 4 and 5, 12.
Right, because again, variable's already positive. What am I doing into it? Subtracting 2 and 1/4. How do I undo it? The opposite. Add 2 and 1/4 to both
And
sides.
then the common denominator is 12, so 3 12s,
Yep.
and then 5 12s, and then you add those, which is 8 12s, and then 4 5 6, and then simplify it
Mm-hmm.
to 6 and 2/3.
Right, 6 and 2/3.
Should I answer it?
Sure.
No.
There we go. Okay. Questions?
Yeah.
No questions?